Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 14th, 2025, which was about 4 days ago. The big contribution is a massive 3D dataset that finally preserves genuine high-resolution textures and physically based rendering materials at scale, enabling true end-to-end texture and material research. The paper is titled TexVerse, a universe of 3D objects with high-resolution textures. And as we will see later, the implications for content creation and training pipelines are quite significant. Beyond size, the dataset includes structured annotations and curated subsets for rigged and animated assets. Also, the author shared the official GitHub repo. You'll find a detailed README, metadata lists for the full TexVerse dataset, PBR subsets, skeleton and animation IDs, plus annotations and thumbnails. They link download splits for 1K to 8K textures, note licensing per model, and provide contact info and a BibTeX entry. Alright, this opening figure showcases the breadth of assets and the crisp textures the dataset preserves. Focus on the full collage of objects, which ranges from detailed armor and ornate masks to everyday items like cameras, hats, and cupcakes, all rendered with visible material cues like metal roughness, fabric weave, and leather grain. Building on that, the mix also hints at PBR coverage, with metals, plastics, wood, and cloth represented, signaling support for downstream rendering, material learning, and animation-ready assets. Moving to the comparison table, the rows line up major 3D datasets against 4 columns: dataset name, object count, type, PBR material, and high-resolution texture. The headline is straightforward. TexVerse sits in the both category with 858,000 objects, and it checks both PBR and high-resolution texture. By contrast, several synthetic or real scan sets miss one of these two properties, while Objaverse families only partially cover them via subsets. Next, this multi-panel figure summarizes coverage and quality at a glance. First, focus on the whole graphic. It combines category spread, tag trends, and texture statistics. The left bar chart shows totals and subsets, where high-resolution textured and PBR counts stand out. The center donut charts compare texture resolutions, with TexVerse skewing to 2K, 4K, and even 8K, unlike Objaverse. Finally, the right bar chart breaks PBR channels by resolution, highlighting strong metalness and specular availability at 2K and 4K. Now we get a side-by-side texture comparison that really lands the point. Look across the full graphic. The left column shows 1024 textures, while the right column shows genuine high resolution at 4096 and 8192. Notice the hat band and rivet on the top row, and the lion's mane on the bottom row. The higher resolutions preserve pores, scratches, and fine fur strands that blur away at 1024, confirming that the dataset retains true high-detail variance. Building on the texture coverage, this figure illustrates the 3-sentence annotation format and how it grounds to thumbnails. First, focus on the whole layout showing prompts at left and thumbnails at right, with chat-style bubbles displaying the generated descriptions. The top block shows guidance, overall summary, components and spatial relations, then fine details like texture and color. The 2 examples below demonstrate consistent structure that names parts, positions them, and highlights material cues useful for retrieval and training. Continuing with materials, this 2-row panel shows a 4K shield example across core, physically based rendering channels. First, look across the full grid to see consistency between render, albedo color, metallic mask, roughness map, and normal map. Then, notice the close-ups below. The wood grain, metal nicks, and engraved patterns remain crisp, while the metallic and roughness maps separate shiny rivets from worn wood. The normal map adds fine relief that drives lighting detail. Bringing it all together, the key gains are clear. Genuine high-resolution textures across millions of instances, and broad physically based rendering coverage with metalness and specular workflows, plus structured annotations that make retrieval and training easier. These pieces unlock end-to-end texture, material, and animation research. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.